Hello guys, how are you doing? So before I say anything, I want you to picture a scene. Imagine a 15th century young physicist sitting under an apple tree engrossed deeply in his thoughts. Then, out of nowhere, a seemingly mundane event occurs. An apple attached to the tree suddenly falls right in front of him. Now, although the event is seemingly mundane, this sparks an idea in the young physicist's mind. He thinks, why did the apple really fall down? Why did the apple not fly upwards or sideways? Why did it have to fall down only? He goes back to his room, thinking about the same thing over and over again. And after a few years, he comes out with two of the greatest theories of classical physics: the universal law of gravitation and the three laws of motion. So by now, most of you, I'm sure, have figured out which physicist I'm really talking about. I'm talking about the father of classical physics, Isaac Newton. Newton, in his book Principia Mathematica, explained why objects move the way they move. So in many ways, we can also call him father of dynamics, the branch of physics that deals with the causes behind each type of motion. Now, this chapter that we are studying is also a dynamics chapter, as it deals with causes behind several types of motion. So just like any good story, let's begin our dynamics story right away. So our story of dynamics begins with the concept of force. Now the term force is not new for you, right? As you've already learnt it in your previous standard. So force is nothing but a push or a pull action that leads to certain outcomes. For instance, a force can change the state of motion of an object. Now, some of you video game and cartoon lovers might have forgotten what the term state of motion means. So let me quickly redefine it for you. The state of motion of an object essentially tells us whether an object is moving or whether the object is at rest. So an object can only have one of the two states of motion: rest or motion. So when we say that force is capable of changing the state of motion of an object, we are essentially saying that force is capable of making a resting body move, as well as force is capable of making a moving body come to rest. Essentially, this means that force is capable of changing the speed of an object. Apart from this, force is also capable of changing the direction of a moving object. Classic example of that would be a batsman striking an oncoming cricket ball. When a batsman strikes a cricket ball, both the speed and direction of the ball change instantly. And finally, guys, force is also capable of changing the shape or size of an object. Or in other words, force is capable of causing shape deformation. And there are numerous examples of that. Now, force is a physical quantity that needs both magnitude and direction to completely define it. This means force is actually a vector quantity. The SI unit of force is Newton, certainly named after the great scientist Isaac Newton. Now, the magnitude of force is defined by Newton's second law of motion, and we'll talk about that in detail in an upcoming video. Now, many times an object experiences a set of forces or a combination of forces instead of just one force. For instance, you can see a block being pulled by several people over here. So what do you think is the final direction of the block's movement? Where would the block move? You see, that depends on the resultant force. And the resultant force is nothing but sum of all the forces acting on the object. However, I must remind you that force is actually a vector quantity. So when we are adding forces, we must take into account their directions. So what do you think is the resultant force in our case over here? Take some time and think about it. So first of all, guys, we'll choose a sign convention over here. So I'm going to choose right side as positive and left side as negative. Now once I do that, my resultant force comes out to be minus F1 plus F2 plus F3 minus F4. All I have done is assigned the respective signs to the forces. Now once I put in all the values, the expression changes to minus 10 plus 20 plus 5 minus 14. Solving this, the resultant force comes out to be plus 1 Newton. So from this I can say that a resultant force of 1 Newton acts on the object in the right direction. Now, when the resultant force value comes out to be a non-zero number, we say that the forces acting on the object are unbalanced. On the other hand, if the resultant force value comes out to be 0, we say that all the forces acting on the object are balanced. Now, this is a pretty intuitive idea, right? If the net resultant force is 0, the forces acting are balanced. If the net resultant force is non-zero, the forces acting are unbalanced. However, let me augment this with an example. So, if two guys capable of exerting equal amounts of force push a block together in the same direction, we have a non-zero resultant force. And in that case, we can say that net force acting on the block is unbalanced. On the other hand, if the two guys apply forces on the block from opposite directions, we'll have a net resultant force of 0. And in that case, we can say that all the forces acting on the block are balanced. Now, before I end this video, let's talk about some common forces that we'll encounter in this chapter. The first force is the normal reaction force. The normal reaction force comes into play when two bodies are in contact with each other. So this means that normal reaction is actually a contact force. The normal reaction always acts perpendicular to the surfaces in contact. Taking an example, consider a block placed on your palm. Now the block applies a force downwards on your palm, and your palm applies an equal and opposite upward force on the block. So the force applied by the block on your palm is the normal reaction force, and the force applied by your palm onto the block is also normal reaction force. The next contact force that we have is nothing but the force of friction, which we also simply call friction. Now, as you already know, friction is an opposing force that opposes the relative motion between any two objects in contact. Now, friction is of three types: static friction, sliding friction, and rolling friction. Static friction acts between the objects which are not moving with respect to each other. Therefore, static friction only opposes the tendency of relative motion between the objects in contact. On the other hand, sliding friction acts between the objects which are already sliding on top of each other. And finally, rolling friction acts on an object which is rolling on top of another surface. The next force we have is the force of gravity, or the gravitational force. Now, as you already know, gravitational force is a non-contact force. The planet Earth, on which all of us live, pulls every object towards its center with a certain amount of force. This force is nothing but the gravitational force. Now, by definition, gravitational force is the force with which any two objects possessing mass in our universe attract each other. Now, we'll talk more about gravitational forces in the upcoming chapters. But from your previous standard, you already know that objects like the Earth, the Moon, the Sun, and the other celestial bodies that are really massive exert considerable amounts of gravitational force. Now, very soon you'll observe that several objects move purely because this force acts on them. Therefore, gravitational force has a major role to play when it comes to dynamics calculations. And finally, let's talk about the force applied by a string. The string is peculiar in the sense that when it's tied to an object, it applies a pulling force only when it's taut. If the string is slack, it applies no force on the object it's tied to. Now, the force applied by string is also called the tension force. And with that, guys, let's end our video today. I hope you had a good informative session on the topic of force and its types. Now, in the next video, we'll talk about some experiments conducted by a famous scientist named Galileo and various conclusions that came out of it. Now, I should tell you that the conclusions that came out of it was used by Newton himself to formulate his first law of motion. So for now, let's summarize what we have learned in this video. A force can change the state of motion of an object. A force can change the direction of motion of an object. A force can change the shape or size of an object. When a set of forces act on an object, the object ultimately moves in the direction of the resultant force. The resultant force is calculated by adding all the forces acting on the object while keeping their directions in mind. When the resultant force comes out to be a non-zero number, we say that the forces acting on the object are unbalanced. On the other hand, when the resultant force comes out to be 0, we say that the forces acting on the object are balanced. Normal reaction is a contact force that acts perpendicular to the surfaces in contact. Friction is a contact force that opposes any relative motion between two surfaces in contact. Friction is of three types: static friction, sliding friction, and rolling friction. Gravitational force is the force with which any two objects possessing mass in our universe attract each other. Tension force is a pulling force applied by a taut string on any object that is tied to it.